Shailesh Kumar, currently Chief Data Scientist at Reliance Jio. Program Mentor for the AIDS program at Jio Institute of MLE. He has also worked with Ola Cabs and also was a co-founder for Third Leap. Can we welcome Shailesh with a big round of applause, please?
Yeah. Do we have a clicker in the slides up there? All right. So this was a topic given to me, but I'm going to speak what I have to speak. Yeah? This is the mark of a good leader dealing with a reporter, right? You have to answer the question you want to answer. But anyway, it will have some relevance to the topic. So what I'm going to talk about is, I'm coming at you as a customer of your data products, right? So I'm coming as a chief data scientist who is now talking to data engineers and data ops and data guys and saying, this is my requirement. So think of it like a requirements document, and hopefully that kind of a thing will come in handy. Now, if I look at the origin of data and the evolution of why we started collecting data, the first data was collected by a software engineer. You know, my software is going to go bad. I need a log to figure out what the problem is. So debugging was the first use case of data. Then came the dashboard people, and they said we need to now do all these dashboards. And now we are heading into decisions and saying, can data drive decisions? So the use case of data has evolved over the last 30 years. And hopefully we understand this journey. And we also understand why data is still in silos, because microservices architecture requires data to be in silos. Right? It's not by design. So when data was being used in organizations in the last 30 years as an IT organization, it was for IT use cases, right? I want the customer 5 fields here, 5 fields here, 5 fields here, but you as a data scientist need all of this together and we have a problem, right? So obviously we are dealing with a legacy system at a fundamental level. So what I'll do is I'll break my talk into two parts. One is the, three parts. One is the context where we are in. And obviously the big context in front of all data science people and all data engineering people is what AI will do for humanity, right? And when Sundar Pichai says that it is one of the most, profound things mankind has done in the face of inventing fire, inventing the internet and going to Mars, AI is still one of the most profound things. What he's talking about is not what we have done so far. He's talking about the future potential of AI. We have not yet affected the lives of farmers and teachers and doctors and patients. We have still only worked on commercial applications, but the real potential is yet to be seen. So I think there's a lot of work that will happen in the next 20 years, and I want to paint that picture and kind of prepare us for what is coming in the next 20 years. Yeah? So if I look at the products, how they have evolved, right? We started with, physical products that came with programmed intelligence. And then we moved on to, digital products, which came with the ability to learn over a period of time and become intelligent over time. And now we are heading into the next 20 years, which is what I call product 3.0, which are ecosystem products, right? A smart city is a product. An entire, telecom network is a product. So if I think about, what the future products are going to be, they are going to be very, very different than what we think products are today, right? So we think Tesla is a product, and let's say Google Maps is a product, and RFID and GPS as a product, but coming together of those products to create a connected car ecosystem is the next product, right? So integration of what we have done so far into a bigger and bigger ecosystem is what we call an ecosystem product. Yeah? So now how do we look at it from a data science point of view? We start with what is stimulus data, and this is an example from Ola, the diversity of it, right? So you can get data from customer app, driver app, third party. The first act of creativity in data science, we try to come up with the state of everything. What is the state of a location, state of a driver, state of a cab, state of a ride, state of a customer. And then we think about converting states to action, like the previous speaker was saying. Unless there are actions, we don't see the ROI. And then on the other side of this, we have metrics. And now we are using the same stimulus data in the future to create metrics. And then we are learning whether we have done the models right, whether we have done the actions right. So we are learning all that, and this cycle goes on for years until we get it right. So this is the framework, this is the context. Now, I'll talk about data in a very diverse sense. When we thought about data 20 years ago, it was an Excel spreadsheet with rows and columns. Now we know that data is a lot more than that, right? So let me talk about it from multiple perspectives, right? So if you look around, we are surrounded by sensors, right? I'm not talking about an ICU patient who is looking around and surrounded by sensors. We are all surrounded by sensors. Our phone has sensors, our car has sensors, satellite has sensors. So in a way, we are a sensor civilization. And every sensor that was created long time ago has become much better now, right? So whether it's a satellite, it has higher resolution. Whether it's a phone, it has much higher resolution, right? So everything is becoming better. More sensors are coming. COVID test is a sensor as much as an X-ray. So we are a sensor civilization. And a lot of times data scientists don't think about sensor as an important source of data, right? And when we say sensor, we think of a device like a thermometer or a thermostat or whatever. But really sensor can be many, many things, right? A transaction that is happening, log is collected is sensor, right? Images coming out of this and that is sensor. Videos from there, different app logs is sensor. So Paytm is actually a sensor. Google search is actually a sensor, yeah? Telecom is actually a sensor. Banks is actually a sensor. Anything that generates data is a sensor. So the idea of sensor has to evolve in our mind that everything that we do, whether it's a digital product or a physical sensor or an instrumentation coming out of a device, all this is sensor, right? So we are a sensor civilization. We understand that, every feedback. So the diversity of sensors, therefore the diversity of data, right? The second thing is because we are a sensor civilization, we are a data civilization, right? So today we are a data civilization, but when we say data to different people, it means different things. So I'm going to create a bigger picture around what do we mean. So when we say stimulus is one type of data, right? Every log entry that you get, whether it is IoT or transaction based, is stimulus kind of a data. This is also data. This is what we think data is. That's all we think data is, right? Data is a lot more than that. The other type of data which is not getting enough attention is what we call knowledge or a knowledge graph, right? The static data of an organization, right? What are the lat longs of a cell tower is a static data which is as important as, each call getting logged. So that is stimulus data, this is static data. Knowledge graph is going to become and is a very important part of your data strategy. Yeah? Feedback data, again, whether we think of Twitter, ratings, or any kind of rating system. Feature lake, everybody talked about. Today, one of the biggest missing links between, we are buying Azures and Tableaus and all these tools, but the big problem is every domain has its own specialized features, right? Every domain has its own data variety. And how do we master the art of creating, maintaining, managing features? So features as data. Raw data you can throw, features you can keep forever, and now you can use that in the future one. How do you create an exhaustive notion of features? Not because you need them, but because you can create them. We need to switch this idea because today you are capturing 10 features, tomorrow you're going to need 50 more, but you could have captured those 50 more earlier, but now you lost that because you had to delete it. So the feature thinking is, I will create a feature because I can, not because I need to, because it may be useful 10 years down the line for some other reasons, right? So feature thinking, we have to think very, and therefore feature products are now coming up, and everybody is trying to figure out. Every prediction that a model does is also data, right? So I have a churn score of a customer, where does it go? It is not lost in the whole thing. It also needs to be stored because I need to track whether the churn score is going up and down. So in a way that becomes a feature going back to the feature link in some sense, right? So anything that a model generates is also data. Every reason code that a model generates, why is this high, why is that low, is also data. So I need to know for all the audit reasons and compliance reasons we talked about, right? Then all decisions I have generated in the past. I increase the credit limit of this person by this much. That also is data. I need to store that because I want to learn from wrong decisions to right decisions later, right? And every metric is also data. It's not just that after dashboard we are done. The metrics need to be tracked forever. And every domain has very, very fine nuances. If you drill down in every domain, you will see healthcare, computer vision, there are so many types of data, right? Within chest X-ray, there is side view, front view, and whatever else, right? So there's deep, and we all need to think about the data ontology of the company and say, what is that data architecture of the company based on the use cases. We are a knowledge civilization. Knowledge is different, data is different. I distinguish them because we need different terminology. Knowledge is about entity-centric thinking, right? So all entities in your business, whether it's a bank, it's a salesman, it's a customer, it's a device, it's a SIM card, it's a cell tower, all entities in your business have a few properties which are static in nature, right? So what are their attributes and qualifiers, right? Date of birth of a person, location, address of a person. So these are static things, they don't change very often. Predicates, relationship between entities. This cell tower is in this location. This customer comes to this store, right? So how do we think about relationships between entities? How do we think about qualified relationship in the morning, in the evening, on the weekend, on the weekdays, right? How do we think about naming? ID is not name. I am Shailesh Kumar, but my Aadhaar card is my ID because I have so many other people with the same name, right? So how do we distinguish name from an ID? So that name is in all languages, ID is common, right? How do we think about content associated with data? So how do we relate and say these movies or these scenes have these people? X-ray, for example, in Amazon Prime, right? So how do we detect, think about content? So you have a receipt, you can think about store ID with a receipt ID, right? So that's a content associated with data. How do we associate actions with entities? So if a customer is there, what are the possible actions? If a store is there, what are the possible actions? If a device is there, what are the possible actions? How do we think about knowledge in a very generic sense? And what are the metrics associated with an entity? Right? Customer lifetime value, churn score, fraud score, capacity score, credit score. So you have n number of metrics for customer, n number of metrics for a branch of a bank, n number of metrics for something else, right? So how do we organize this space in a very, so what is the dictionary for knowledge graph that we need to create? And it's a very powerful construct because if we can do it well, we can answer very factoid or reasoning-based questions on top of it. And we need both knowledge and data to create features, to create models, to create decisions, right? Both have to come. We are a feedback civilization, and this is the implicit feedback that nobody talks about, which is critical to how Googles of the world have improved their products, right? Implicit versus explicit feedback. Implicit feedback is far more powerful, high volume, unbiased. So for example, every click that you do on Google search is an implicit feedback that my result is good, right? People are clicking on first result versus third result is a click feedback. And Google doesn't want to be in a phone business, but it got into the phone business not because the phone business is lucrative, but because they want to make sure their click data is not going to anybody. The operating system their own, hardware their own, and the browser their own, right? That is how much click data is valuable, right? If you think about conversion rate, so you do a campaign, and if you don't send a customer ID along with the campaign ID, and the customer even clicks the campaign, you don't know who converted. You just know how many links got converted, but you don't know who got converted. So this implicit data collection is an important art because we are not collecting data to collect data and build a dashboard, but to learn and improve our decisions. So how do we go very deep into this, right? Think about engagement. If you have Byju's and they are trying to understand if the student is engaged with their product, what can they do to collect feedback data? Implicit feedback, not explicit. Did you like the video or not? Implicit feedback would be a facial recognition or emotion recognition thing on the camera that is watching the kid and the kid is confused or engaged or not. How do we measure that? Implicit feedback. Payments is a feedback mechanism, right? If I have added a product to my wish list versus I have actually paid for it full price versus I have paid only for half price, that tells me how much is your interest in that product, right? Payment is actually a feedback data. Therefore, Paytm is hiring data scientists. It wants to be a largest ad network in the world because you put your money where your mouth is. So payment is an important implicit feedback, right? Emotion recognition we talked about, right? TV can watch you, you can watch the TV, and now ad companies, TV programs can learn what's going on. So we understand implicit feedback is an art we have to learn, right? Revisits, we all do DAOs and MAOs and all of that, right? Stock out is a very important feedback we are not collecting. Today I walk into a store and say I need iPhone 14, the guy says we are out of it. who is collecting that piece of data. He is not going to his table and saying one customer came and he did not get the iPhone. Why is stock out such an important feedback? Because it tells you whether your inventory levels are good. These are the finer things we need to do to make sure we have an implicit data strategy, not an explicit data strategy, right? So how do we think about that? Query logs, we all understand. Alarms are coming. Are we doing anything? Alarms, low alarms, think of Fitbit. Lower alarms are coming, eventually a big alarm is going to come, right? How are we managing that implicit feedback coming every time, right? Gestures, for example, a lot of applications can start using gestures. So there is a lot of scope of how do we think about feedback, especially implicit feedback. And explicit feedback we all know. And that's not the kind of feedback that we need to worry about. That we already know how to handle and manage. Yeah? And then, so in a way, our requirement is a very comprehensive repository of data, which is all these things coming together, the schema of it and the storage of it. And if we can build this kind of a repository, I'm not thinking about snowflakes or a particular tool. I'm thinking about a semantic architecture that says, I need to know the sale of this in this market. I don't care whether you use this technology or that technology, right? So how do we create a semantic data architecture that can solve all these problems? Okay, I heard a ring. Is that for me? Okay, I'm only half done. Should I continue? 5 more minutes? Yeah, 2 more minutes? Let me speed up. So I'll quickly go through the different workflows which are required for us to build our thing. One is what I call exploration workflow, right? Understand the space of customers, where are more cabs required in evening in 𝗏𝗏𝗏𝗏. So we have exploring our data, exploration workflows. Second is execution workflows, get something done into it, right? So these are other workflows. So if I have a farmer doing this, how do I take this and give him the information back? So execution of my workflows, exploring what is coming out of my data. Third is what we call, exception workflows, finding what is going wrong. Today our dashboards are wrongly done. I don't want a dashboard to tell me what's going on. I want the dashboard to tell me what's not going well. It should bubble up that this cell tower is down, that customer churn score is high. It should not tell me what is the overall average of things. Yeah? So those are useless dashboards, so I'll talk about that. Can I explain my decisions? Why is this customer defaulting? Why is that customer defaulting? Can I do visualizations on decisions and all of that? Explanation workflows, expansion workflows. What are the new opportunities for me to grow the business, acquire more customers, put more cell towers, add more stores, put more warehouses? Can data tell me that, right? More construction is going here. I go to 99 acres. I know where the next construction is. Can Swiggy decide to open a kitchen in that part, right? How do we do this in the expansion workflow? And efficiency workflow, which is about finding inefficiencies in my system, right? People are taking longer to deliver a product, right? Or whatever. So how do we detect inefficiencies and solve for it? And then evolution workflows, we all understand how does data help us to rebuild models with feedback. So these are the 6 workflows that we need to enable through data. Yeah? So the last slide, so what is the requirement, right? At a high level, guiding principles. One is we are going to get a heterogeneous set of data. Images will be there, time series will be there, everything will be there. Can we create a single interface for all kinds of data and hide, especially the abstraction out of it? Right? I only want a semantic data store. I don't care about the technology you are using. Technologies come and go. Right? Real time. Can you push data as real time as possible? Today businesses are not doing real time. We cut the data at the end of the day. How about every hour? However, every 15 minutes. Can we do real time decisions where needed? Semantic layer is very important. I want to be able to give data to a business analyst in his language, right? So he doesn't need to know SQL query format or Google query format and all that. He should be able to access it semantically. And then it needs to be proactive. So the real time, I said first graveyard of data is a data lake, right? Did anybody read that? Data lake is actually one graveyard of data because there the data goes to die really. So if the data is not in motion in some queue and doing something in real time, it is a dead data. So data should go to data lake only when it is done with everything. Has it created all the features it is supposed to create in real time? And has it worked on all the models? Then only it goes to the lake. Proactive is the second thing. Unless the data is pushing itself onto you versus you are querying the data. They are two very different things, right? So alert happen, everybody who needs to know should know, right? So is it proactive? That's why dashboard is the second graveyard of data. Yeah, because nobody knows what to do with the dashboard. Yeah, so we have sold these two products, data lakes and dashboards, but in a way we have done a lot of disservice when you look at real-time next generation systems, right? It should be self-healing. It should know what are my biases, hygiene issues, all the governance issues that we talked about. It should be compliant. Obviously, all this needs to be built in. And it should be monetizable. Tomorrow, we are going to start monetizing data. I am a customer. I'm giving you Qlik data. I'm giving you ag data. I'm giving you retail data. What am I getting in return? So how do we meter who gave me how much data and how am I benefiting them? Monetization of data is going to be another area that we talk. Yeah. So thank you. 20 minutes, I could do only so much, but thank you.